from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this June 2026 lecture series, we are discussing about bioelectric measurement and biosensors in biomedical transducers and sensors. Here our topic is ion-selective electrodes, ISEs. Our real-world problem is electrolyte imbalance, which affects millions of patients worldwide annually. And the impact is misdiagnosis of patient conditions, incorrect treatment protocols, patient complications and risks, increased healthcare cost. And who is affected? Kidney disease patients, diabetes patients, heart condition patients, and ICU patients. And healthcare providers, clinicians, they need a proper diagnostics, and pharmaceutical industry, they need accurate results. See, the need for solution. We have limitations in our existing method like time consuming, high cost, delayed results, sample transport, and gaps in technology which involves lack of portable sensors, limited real-time analysis, need for cost-effective solutions, integration with digital health. And the traditional versus modern, the approaches are compared here. Here analysis time is 2 to 4 hours in traditional. In ISE, which is reduced into 30 seconds. Just think, just 30 seconds. Cost per test is in traditional, it is nearly $50 to $100. In ISE, just 5 to 10. Point of care, no need of point of care in traditional, but in ISE, which provides a good point of care service. And solution opportunity, ion selective electrode, which is rapid and accurate and portable as well as cost effective. See the introduction to ISE. Here the ion selective electrode is a potentiometric sensor that converts ion concentration into electric potential. The basic concept is it measures the ion activity in solution, uses selective membrane, it generates potential difference, follows Nernst equation. See the basic ISE structure. In the first part, in the light blue part, we have internal solution. In the two sides of dark blue, we have internal solution, which is called a reference electrode. And thus reference electrodes, two sides of reference electrodes are used for internal solution, one ion selection. And we have sample solution in light blue. See the ion selective electrode, which is in yellow color. See the liquid junction part, which is indicated in the diagram. The internal solution is discharged to the sample solution. And we have light yellow ion selective membrane. This is a simple sample solution with internal and external reference electrode, and we have green colored ion selective membrane and internal solution, as well as we have voltmeter for measuring the changes. See the working principle. The Nernst equation, which is E equal to E naught plus RT by NF ln AI. Here E is our electrode potential, E naught is standard potential, R is gas constant, T is temperature, N is ion charge, and F for Faraday constant, and A is ion activity. See the electrochemical cell setup. Ion selective electrode, which is in light blue, aqua blue, and the membrane is in black, and we have a bit liquid junction. And the electrode AgCl is represented in orange, and we have internal electrode which is represented in light blue color. See, once the ion selective electrode which starts selecting the ions, then this ions is converted into electric signals for proper measurements. With the help of voltmeter, we can easily detect the changes. See the ISE construction. We have block diagram components like internal solution, ion selective membrane, reference electrode, and solid contact. Here are membrane types which involves solid state as well as liquid membrane. See the ion selective electrode. We have electrode body, and in the mid we have electrical connection, and the shaded areas are called ion-selective areas. Types of ISE membranes, we have glass membrane, solid state membrane, liquid membrane, and crystalline membrane. Based on the application, we choose either glass, solid state, liquid, or crystalline. Glass is mainly used for blood pH monitoring, which is normally used for pH control, which is used in industrial, food and beverage. Solid state for water quality, environmental and industrial processes. Liquid for blood electrolytes, dialysis monitoring and ICU patients. Crystalline membrane, which is used for heavy metal detection, environmental monitoring as well as industrial waste monitoring. And the Nernst equation and the response, and our signal flow, which involves sample solution, blood, urine, dialysate or environmental samples. Here are ion selective membrane, then which selects ion transport and potential generation, then ion exchange, potential development at interface, and reference electrodes Ag, AgCl, internal and external. Finally, differential voltage del E, which is equal to E ISE minus E reference, which is measured in terms of volts in voltmeter. Biomedical applications, we have clinical diagnostics, ICU patient monitoring, dialysis monitoring and point of care testing. We have some limitations. I have listed the limitations and challenges here. And student activity, here I have included group discussion, point of care ISE applications for home healthcare monitoring. These are the assessment questions from GATE, biomedical industry and conceptual. Summary part, the mind map. Today we have discussed ion selective electrodes, definition, working principle, construction, types, applications and limitations, and references for our topic. Thank you.